Welcome back to part 2 of chapter 3. We're going to look at the second portion of graphs. We're really going to be focusing on a two-way table, specifically when we compare multiple variables. So if you had a sample of a population and you're looking comparing two different characteristics of one group of individuals, and what kind of questions can we ask? How do we look at these variables, and how can we display them in the right way? Okay, so let's get started. A two-way table, or sometimes known as a contingency table, is a way of displaying multiple variables, two particular, in this case, two variables related as to one sample from a certain population. In this case, they've sampled students' political preferences, college student political preferences, and they want to know, they asked the students two questions. Number one, they asked what was their political preference, if it was liberal, conservative, or moderate. And then they asked what was their gender. And of the respondents, this is what they responded to those questions. We can look at the purple boxes represent my actual two-way table. In this example, where you have a total set up around the edges, this is considered our margins. This is going to be related to what we call marginal distributions. The total in the table where the two totals kind of come together, this represents our total number of people involved in the sample. We call this sample size. In this case, we have 192 college students. And this kind of brings up what we would consider marginal distributions. I could ask something simple as like, what percent of the respondents said female? You'd say, 77 out of 192 people. Okay. I could also talk about the proportion of respondents that responded moderate, right? You'd say, that's 80 out of 192. I'm talking about the whole group. Okay, this changes a little bit when you change the questions. I could say, well, let's just look at the male group, or let's look at just the liberal group. This is what we consider a conditional distribution. Let's look at a few questions and see if we can determine the differences and how to answer each question the right way. That's going to be the really, for this particular set situation, this is the hardest part. Just reading the question, being careful. Number one, I want to ask myself, who's the population of interest? Who am I really looking at? What's the group I'm looking at? If you can determine that, usually this is relatively easy. So first of all, what percent of the class is male? Well, that's easy. We said that earlier. It's 115 out of 192. So whatever number that is, what percent of that is. It just said of all of the class, right? So I'm still looking at marginal distributions. If we look at the next one, it says what percent of the class considers themselves to be conservative. I'm still looking at the whole class. So when we're looking at the whole class, then I'm still in marginal distribution. So conservative, we had 27 out of 192. And so this one changes a little bit. What percent of the males in the class? Instantly, I'm going to stop. I've now changed it where I'm not looking at the entire group anymore. I'm looking at a subgroup of my sample, right? We can do that because we have the data to separate our groups based on the responses they gave. And so here, we can look at males. We say, well, there is a total of 115 males. So out of that group, that's the total, and that's the 100% now. So this is going to be the denominator I'm going to be working with when I do my fraction. Out of that group, how many are conservative? You'd say, well, that's easy. 21 out of 115 would be the percentage of males that consider themselves to be conservative, right? And this is the next one. It says, what percent of all students in the class consider themselves to be males who are also conservative? So now I've given you two requirements, but I'm still talking about the whole class. So because we're looking at everyone, that means my denominator is going to be 192. So now I'm looking at where do those two categories overlap. So we're looking at conservative and male. And so if you go down, you can find conservative is the column here, and then male is this row here. So where do they intersect? There's 21 out of 192. Now that's still considered marginal because you're looking at out of the whole group, but it's a compound situation, right? You're looking for two things to be true at the same time. That's not always possible. In those cases, you'd say, well, zero chance of that happening. Okay, so that's a couple of questions that you can work through. When you get some of these questions to practice, read carefully, try to identify who's the population or who's the group that I'm looking at first. If it's everybody, that's your total in the table. If it's a subgroup, look at that row or the column and try to figure out which one that is, and then look at the characteristic first. That's what you call conditional probability or conditional distribution when you look at just part of the group. Okay? Now, when you get two-way tables, one of the best things I can do is I'd like to compare something. I'd like to know, does gender have an influence over political preference? In other words, if I looked at the two groups together, could I say, oh, look, males tend to be this way or females tend to be this way? Does it, or does it really not matter, right? Males and females tend to break up evenly, and gender really doesn't play a part in my political preferences, right? Now, I'm not talking about logically reasoning out steps like that. We're talking about statistics and the mathematics behind the table. So what we're going to do is we're going to build a chart that allows us to compare a number of different groups. In this case, we have two, right? Males versus females. I could have had multiples here. We could have did political preference and had three groups, right? But we're going to look at, does gender influence my political preference? One of the best things you can do is to create a stacked or a segmented bar chart and put those up right next to each other and make it look something like this. Now, a couple things. Number one, you can see that the bar height is 100%, right? 10 centimeters is a great thing. You can do this on paper. If you're working in a program, it doesn't really matter. But I'm going to break up those percentages as accurately as I can, and I'm going to make sure to put them in the same order. So when you're looking at one here, look across there. This one's kind of done two things. It's color-coded it, number one, and number two, it's put them in the same order. So the conservatives at the top, the moderates in the middle, and you've got the liberal at the bottom, okay? I can look here, and the question was, does it seem to show a relationship between moderates or males and females on their political preferences? What we're looking for is, are the variables dependent or independent, depending on what you ask it. The easiest way I remember to say this is different dependent. If the probabilities are different, then that would mean that those variables are dependent. In other words, if you're male, you tend to be more this way because you are male, right? Now, this is not cause and effect. I'm not anywhere near cause and effect. We're talking about association, just kind of showing what patterns show up. So if I were going to talk about this, I'd want to talk about two things on a minimum level. What's the biggest difference, right? Or what's the biggest difference? And number two, what is the biggest similarity? And so similarity tends to stand out here. You can look here for males and females. The liberal group looks extremely similar, right? It's almost at, we're going to say 45 or 47% for both groups, right? Not a lot of difference at all here. But if I look up at the conservative group, you can tell here that the males conservative group is at least twice as large as the female conservatives. So it does seem to matter that in the conservative group, and it's a yes or no thing. You can say, well, yes and no, because they're not all three groups, they're not all very similar to each other. We're going to say that it does seem to have a little bit of influence. I'm not going to qualify how much or how little. That's a lot later on. But we can show here that because the probabilities or the percentages of the different groups don't match up very well, okay, specifically the conservative group is way different, we would say that it does seem to have some sort of relationship. Males tend to, in the conservative group, okay, there tends to be a higher percentage of males than females, right? Give a reason for why you're saying it's dependent, because which one was different. If you're going to say this was definitely independent, then you would say that all three groups tended to have similar probabilities or percentages, and therefore it doesn't seem to have any relationship at all. So you would say they're independent of each other. Okay? So today we talked about how to read marginal distributions, conditional distributions, and 3, how do we take a two-way table like that, create a chart to be able to compare them together visually, and 4, how do I determine if something is dependent or independent based on the probabilities of the conditional distributions and even marginal distributions. Okay, I hope that was really helpful. I'll see you guys next time.